We've talked about two of our three formulas that we can use to find slope. One of our slope formulas was rise over run. The next one was the subtraction fraction, m equals y2 minus y1 over x2 minus x1. The third slope that I'm going to use comes directly from the definition of slope, which is the ratio between vertical change and horizontal change. And so this last formula looks like this. It's called delta y, it looks like a little triangle, over delta x. And we're going to use this when we're given a table. So I'm going to put over here for a second. So this little triangle, again, it's a Greek letter. It's called delta. And so when I see delta y, I'm going to read that as the change in y, or how much is y changing by each time. So for example, let's say the temperature this morning was 27 degrees, and then by the afternoon it was 40 degrees. That would be a change in temperature of 13 degrees because the temperature is going from 27 to 40. So that's what this is asking us to find. It's asking us to find the change. And so this is going to ask us to find the change in y, which is similar to finding the rise, but we're just going to do it in a table, and then the change in x. So we're going to start by using that formula. So let's go to the last page to focus on these table type problems, and then we'll come back and do some more stuff on the front. Okay, so hopefully you've switched to page number 4. So the difference here is I've got 4 tables, and these, if I were to plot them, they would represent a line. They would be linear. And I want to find the slope. So I can't use rise over run, I'm not in a graph, and I wanted to use subtraction fraction, I'd have to set up ordered pairs. But we're going to try using this third formula, which is delta y over delta x. I'm just going to kind of put that here for a second. Delta y over delta x. So for my table, if I look at my x column first, then what I see about my table is x is starting at -4, and it's going to -2, and then to 0, and then to 2, and then to 4. And so what that means is that each time the change in x is going up by 2. Now if I do that same thing with my y is going from -16 to 10, from -10 to -4, from -4 to 2, and from 2 to 8. And so that means my y each time is changing by 6. And so I just want to put these numbers into this formula. M equals delta y over delta x. And so that's going to be 6 over 2, which will simplify to a slope of 3. Let's try example 15, and then I'll have you try examples 14 and 16. So the only difference here in 15 is that my table is on its side, but I can still see here's my x row this time. And so what I see about my x is going from 0 to 2, then 2 to 4, then 4 to 6. So every time my x is changing by 2, so my change in x is 2. My y is going from 5 to 10, from 10 to 15, and then from 15 to 20. And so my change in y is 5. And the formula I'm using again is that slope equals change in y over change in x. My change in y was 5, and my change in x was 2. So it's just really important that you put those numbers in the right place. And I would leave my answer as 5 over 2, because I remember slope is a ratio of like rise to run, or vertical change to horizontal change. So I don't want to change it to like a mixed number or anything. Your turn to practice. You're going to try examples 14 and 16. Pause the video, press play when you're ready to check your answers. Remember that you're using the formula m equals delta y over delta x. So on example 14, my x is going from -3 up to 7 to 17, 27, 37. So change in x each time is 10. My change in y is going up by 5 each time, so change in y is 5. Change in y, which is 5, over change in x, which is 10, and that would reduce to 1/2 for a slope of 1/2. Then this time I've got my sideways table, so x is going up by 3 each time, that's my change in x. Y is going up by 9, so that's my change in y. 9 over 3, change in y over change in x for a slope of 3. So let's turn back to page 1 just to kind of finish filling some things in on this page here. So yesterday, one of the things that we talked about was in this bottom box here that had to do with the direction. And we just mentioned that this line has a positive slope and this line has a negative slope. And if you think about the penguins that we had our penguin going uphill or a penguin going downhill. And we also had a penguin at one point going flat, and we'll talk about this box in a second. So the reason this is a positive slope is because anytime we read, we always read left to right. Now on a graph, when you move left to right, you're moving right on the x-axis, and so your x is increasing. So what's happening with a positive slope is that as x increases, because we're going left to right, y is also increasing. So that's because as I'm moving in this direction, the line is going up. So that's going to be a positive slope. A negative slope, I'm still reading left to right, so I'm still moving that way on my x-axis. I'm moving to the right, so my x is still increasing. So I'm just going to say this the same way. So as x increases, because I'm still reading left to right, but this time y is decreasing. So as x increases, we're always looking in that direction. This time y is going down. Positive slope as x increases, so left to right, the y was going up. So that's really what makes these either a positive or a negative slope. Now for a zero slope, and if you saw in the slope do video, this is when he was skiing and said this is 0 fun. So this is going to be my slope of 0. And I can define this if I use the same kind of sentence here. So as x increases, I'm moving left to right on my graph. This time y is staying the same. So as x increases, y stays the same. I guess you could also say that y has 0 change, if that helps. Then we also saw in the slope do video that this was kind of towards the end here, and this is going to be our undefined slope. So I'd have to write out that word. And the reason I like to think mathematicians chose this word undefined is because the previous 3 definitions of slope for positive, negative, and 0, they all started with as x increases, because in each of these cases we were moving left to right on the graph. By the time we get to the undefined slope, the x actually isn't moving at all because the line doesn't have any left to right movement. So I like to think of it as undefined because we can't define it in the same way. We can't define it as starting with as x increases. So we're just going to kind of leave it at that. We'll come back and add a few more pieces of information here in a minute. We've just got another investigation to do. Let's turn to page 3 where we did our subtraction fraction stuff. So on page 3, yesterday we did subtraction fraction on examples 7 through 10. We're going to scroll down and look at examples 11 and 12. So the first thing I'm going to do is I'm going to set up my subtraction fraction because I have 2 points, and so that's the method that I would use to find my slope. I'm going to do that on both of these. I'm also going to label my coordinates. So x, y, these are my 1s, these are my 2s. I'm going to do the same thing over here. And I'm going to start to plug in the information. So on example 11, it's going to be 4 minus 4 over 3 minus 2, because that's y2 minus y1, x2 minus x1. And then over here I've got 3 minus 1, that's y2 minus y1, over 5 minus 5. And so if I do this out, I'm going to get 0 over 1, and I'm going to get 2 over 0. Now before I take this a step further, because I always have to simplify my answers, one thing I see right away is that both of my answers have a 0 in them, but they have them in a different spot, and that's going to be really significant. So before I investigate this further, I'm going to draw a quick sketch of these points on this little graph that I created. So the point 2, 4 would just be over 2 up 4, and the point 3, 4 would be over 3 up 4. And so I've got those 2 lines, and if I were to sketch them, it would look like that. So I'd have a horizontal line. Now if I think about back on that first page where I was drawing like my formulas and looking at different positive, negative, this type of a line, which was horizontal, has a slope of 0. So what that tells me is when I plotted these and I ended up with this answer, this is actually going to simplify to 0. So that line has a slope of 0. Now let's do the same thing but with these 2 points over here. So I'm going to plot the point 5, 1. So that would be over 5, 1, 2, 3, 4, 5, up 1. And then the next one would be over 5, up 3. And so this time, if I were to connect these 2 points, I end up with a vertical line, and I know from that front page that a vertical line is undefined. So what that means is that if I end up with a 0 on the bottom, my final answer that I'm going to say about my slope is undefined. Do me a favor. open your calculator app or use a calculator, and the first thing, I'll pause the video, the first thing I want you to type into your calculator is this math problem right here, 0 divided by 1. Pause the video while you're doing that, press play when you have an answer. Hopefully when you typed in 0 divided by 1, you saw that your calculator spat back an answer of 0. That's kind of what we expected, so the calculator can help on this. Now I want you to take your calculator and type in this math problem right here, 2 divided by 0. Pause the video, type that in, see what you end up with for an answer. So this time, depending on what kind of a calculator you have, it might say something different. But when you type in 2 divided by 0, it doesn't give you an answer of 0. Instead, it probably gave you either an error or something like invalid domain, just something that you're not expecting from the calculator. So that can kind of help you remind your brain of what's going on. So you could type it in, and if it's 0, it would give you an answer of 0. You could type it in, and if it's undefined, it'll give you some kind of an error message. And we're not going to say error for a slope, but we can say undefined. The other thing that can help you visualize this is like we did here, where we made a sketch, and we can see that a horizontal line we know that has a slope of 0, and a vertical line has a slope of undefined. Let's turn back to page 1 just for one more second to add one extra note to our slope information. So the last thing that I want to add here is in this box for both 0 and undefined slope to help us give a little reminder of how we might differentiate between the two. So one thing that we saw is that in the subtraction fraction, in both cases, we got a 0 in the answer. When the slope is 0, it's going to be 0 on top and then over a number. So that would simplify to 0. When it was undefined, we got the number on top and the 0 on the bottom. And that we're going to write for our final answer as undefined. A little rhyme that a teacher came up with a long time ago was if the 0 is under the line, it's undefined. So if you can get that rhyme into your head, that might help you differentiate between 0 and undefined slope. But the key here is that if your subtraction fraction has a 0 in it, you need to take that one step further and either simplify it to 0 or simplify it to undefined. You can either use this rhyming trick, or you can draw a sketch, or you can use your calculator. 0 divided by anything is always going to be 0. A number divided by 0 is always not possible, and so we're going to take that to know that means undefined.